Irish marketplace. And in a continuation of that theme, we were delighted last month to announce our channel partnership agreement with Analog Devices. Now, this partnership agreement involves the rollout and support in Ireland of the Analog Devices smart motor sensor, known as the SMS, for predictive maintenance of electric motors. Now, the SMS product falls generally under the banner of Industry 4.0, and one of the things we'd like to do today is to give you better insight into what Industry 4.0 is and how it can bring huge benefits to you in your working life and to the business you work in.
We said welcome a couple of times, and my own name is Mike Morrissey, so I'm responsible for the Catalyst initiative, which I hope to explain to you in a couple of slides of what we're trying to do in a very short video as well of what Catalyst is designed to be. I'm not going to cover ADI as a company because Kevin will do a much better job than me, and he's going to cover some of that in his slides and what Analog Devices is about. What I'm going to focus on predominantly is the parts that Kevin hasn't in his slides, and that's maybe a bit about Ireland and how long we're here and what type of technologies we have going on in the Irish site. But overall, you know, we've recently acquired Maxim Integrated, for those that don't know. So that acquisition just closed there about 6 weeks ago, and we're currently integrating the two companies. So we went from a $6 billion to over a $9 billion company, and Kevin will talk a bit about this later on. We've a huge range of products where we play heavily in automotive, communications, and industrial is our main area, which is why we're here today. So, but where did we come from? The company itself is around since 1965, but ADI Ireland is here since 1976. And I like showing the picture back in 76. You can see we were part of the advanced factory. That was the size of the estate, and where we are sitting now is up in this green field here. Not even in the original estate. That's the Striker building straight across the road there. And I think the background is really striking, you know, the number of houses that are there. So ADI was one of the first factories. I think Striker was first and we were second in the estate. That was a factory built by the IDA. That's where we are today. So you can see we're in this building here, the Catalyst building. And it now takes over 32 acres with over 600,000 square feet of building space. We've two semiconductor fabs facilities straight 5 minutes walk down in that direction. There. And we opened up our ERDC in 2015, so that's where all our research and development engineers are housed. You know, it's a state-of-the-art building that was opened to house. We had a number of sites around the campus. About 7 different buildings, so we brought everyone together, our R&D engineers, into one to make it more collaborative. And then in last year, just before COVID, we opened a collaboration centre here. So in April, and we closed down in March. So typical of the timing of how many people get caught in it. And I think just if you see the background as well, it's always interesting. You see the number of houses and how the whole area has grown over the years. We have about 1,400 employees now, so we have a site the main site is Limerick here, about 1,200 employees. Then we have 100 in Cork and about 100 now in Dublin with the new acquisition of Maxim. And I think what's really interesting is about 820 of those 1,400 employees are focused on research and development, either in product development or in advanced manufacturing. So it is a huge amount of engineers focused predominantly on R&D, and we're very proud of that. So what we decided to do, Analog Devices always been a very collaborative company. We always like working with partners, with either be business partners, technology partners, customers, or research institutes. But in 2017, we purchased this building. We were renting it, and as you can see, it's very close to right adjacent to our other buildings. But we decided to purchase it in 2017, and then what are we going to use it for? So one of the areas, and it was our SVP who's responsible for industrial, Martin Cotter, decided what we need to do is work with customers to solve their problems at their level, as in what the problems they're incorporating now. We had our incubator space, which was in Boston, which is called our ADI Garage, and that's very much work with research institutes and blue sky research, predominantly, is what they were designed to do. We wanted to take problems that a customer is facing now and work on it and get it resolved and the time to market quicker. So that meant bringing teams together. It's not like people working together on the problems to solve them quickly. So that means bringing people together, teams together, to solve those problems and deliver the solution. So there's one, John O'Donnell is here. There's one, John used to be ADI and he's now with Johnson & Johnson, and I know he won't mind us talking about it. But we have a collaborative program with John and the team working on time-of-flight safety sensors, so putting our safety sensors onto some of the robotics that are going to be delivered into the advanced manufacturing sites in Johnson & Johnson. So it's those type of projects where the teams work closely together and solve the problems quickly, and deliver it into where we need it. So we're not really designed to do blue sky research. We're designed to do rapid prototyping and deliver those to try accelerate it. The areas we're focusing on predominantly are industrial, which is probably our main, is our tenant here, and then we have some technologies in the rear. And over in the new area on automotive and communications. So we're an analog devices company very involved in 5G, 6G in industrial, but as to service all other markets as well. And obviously automotive is very strong in Europe. So we're really focusing on the trends that Europe is strong in, and industry 4.0, automotive and communications are really the trends in Europe. Very short video, 90 seconds. So maybe give a bit of better background to Catalyst.
ADI Catalyst, a space where we collaborate, connect and co-create with our customers, partners and suppliers. ADI Catalyst is about a new way of working, where we take a partnership approach in helping our customers resolve the challenges they face at an accelerated pace. With our 100,000 square feet facility, we are providing a unique working environment, a space where our customers, business partners and suppliers can interact with our people, technology, expertise and support infrastructure to collaborate, innovate and solve together. ADI Catalyst is multifunctional. It provides a temporary workspace for project teams to come together, and its size and capacity means we have the flexibility to create customized labs where ideas can be brought to life, or introduce pilot lines where we can test systems and technology in a simulated environment. ADI Catalyst is ideally situated within the ADI Ireland campus, with access to our major business units, technology groups, sales and global operations. This means we can assign the right people, resources and technology to achieve a solution. Our research partners are also on hand and ready to help us co-create solutions for Industry 4.0, healthcare, communications, transportation and so much more. ADI Catalyst. Let's solve together.
This last one or two slides, just and I won't dwell on them, but because the focus here today is AutoSense, which is obviously a fantastic product, and I hope you get a good feel for it for today. But we do have a huge amount of other technologies that we work on in industrial automation and energy. In each areas in digitalization, sustainability and automation, buildings, infrastructure, energy in the grid, and obviously hugely amount in factory automation is a key focus area for us. These are some of the areas and how we develop different edge analytics for machine health, which is very much AutoSense, but we do Ethernet for IT, OT solutions, and I think some of the team is here as well that work on that today. High-speed communications, working on robotic operating systems, the open source versions, analytics for robot help, a lot of work in software, edge processing and out to the node, and again you have some experts that work for Kevin in that area as well. So we have a number of solutions across different technology nodes that again very exciting products and some that we're very, very, very proud of. So I won't dwell on questions. Maybe we can have questions at the end, but in the interest of time, I'm going to thank you, and I'm around. Hopefully someone will be able to have a chat after. I'm going to hand over back to Austin again to introduce Kevin.
As you mentioned, we're joined this morning by Kevin Carlin, who's flown in from Boston to be with us this morning. So Kevin is Vice President of OtoSense Analog Devices. He's held a wide variety of roles in the semiconductor industry over the past 25 years. Prior to leading the OtoSense business for ADI, he was the Vice President of Industrial Automation and Energy for ADI. Kevin spent 15 years in Europe, leading the Central Europe sales organization for both TI and ADI. He spent 12 years in Munich, Germany, and is fluent in German. He holds a bachelor and master's degree in electronic engineering and DSP. Kevin is originally from Belfast and currently resides in Boston. So hand you over to Kevin.
Good morning, everyone. Thanks for the intro. I don't need to cover any of that. Great to see everybody here. Welcome to Analog Devices here in Limerick, and it is just wonderful to be with people physically after this interesting period of time. So what I'll do is maybe talk a little bit more about ADI. Some of you may not have any exposure to analog devices, kind of wondering why you're here with us this morning, and I'll try to join the dots with what brought us to today, what brought us to this great collaboration with O'Neill. And I'll just talk to you about kind of where we've come from, the direction we're going in, and how these innovative technologies and partnerships are aligned with the large, mainstream megatrends, global megatrends that we're highly tuned into. So this ADI OtoSense is a brand that we used. It came from an acquisition actually that we did in California a few years ago, a company called AutoSense, and the founder and CEO of AutoSense is part of my organization, and we decided, well, that's a pretty good brand, so let's keep it, and we'll attach the ADI to the front end of it so that we have some connection to the mothership. But we also wanted to separate ourselves from the mothership from a brand perspective, because we were creating something new. And actually what we do with ADI OtoSense is somewhat linked to historical ADI and semiconductor. But in its core and its essence, it's actually going way beyond, and it's a bit of a departure from what we're used to. So I'll try to explain what that means. But first, just a little bit more info on analog devices. As Mike pointed out, 1965, the founder of Analog Devices was an ex-MIT grad and professor. Actually founded the company out of a garage in Cambridge, Massachusetts. And so that incubation field that we have over in Boston, we call it the ADI garage as well. And that's really looking at the next 5 to 10 years out, bleeding edge technologies. These numbers are slightly out of date because they've all just increased because of the integration with Maxim. But we serve an enormous amount of customers through distribution channels and direct globally. We're in 38 different countries. The presence here in Ireland since 1976 is one of the most important sites that we have. There's bleeding edge technologies that are developed in the buildings next to us, and also the manufacturing process technology. So the IP and the experience and the intelligence of the Irish piece of Analog Devices is critical for us and for our future. And actually, there's our CEO is a fellow from Wexford, came up through Limerick University. A lot of our senior staff over the years have come through this facility as well. I myself have no connection with ADI Limerick, apart from visiting quite often, but originally from the north. I made my way through various roles and countries and so on, but always great to get back here and to see everything that's going on. And the Catalyst Center this is just the beginning of what this place is going to be. So lots of products, lots of customers. When I joined 13 years ago, we were about a $2.6 billion company, 50% of the revenue through the industrial markets. As of a couple of weeks ago, we're a $9.6 billion company, and I think we'll break through the 10 billion probably in the next year or two. We're founded really on innovation, really bleeding edge technologies. And what's changed is just from individual products to combining products to adding software, broadening the portfolio, and it's all about solving more and more customer problems. And this innovation center is about getting closer with customers and partners to solve more complex problems. Everything from data centers to automotive, communications, so from millimeter wave to RF, 5G communications and beyond. Digital healthcare in general, Industry 4.0 and green energy. So again, 50%. I think if you combine the industrial, the healthcare, and aerospace and defense business, it's about 55% of that $9 or $10 billion. And a little bit of consumer in the professional handset business as well, but it's mainly B2B businesses. So where does the innovation come from? Well, actually we're spending more than anyone in our industry in terms of percentage of revenue into R&D. So the combined Maxim ADI spend on R&D going into next year will be something like 1.4 billion. As a percentage of sales, it's much higher than the industry average in semiconductor. And the reason why we do that is because we get to solve more complex problems. And our value is around innovation and making sure that we're on the bleeding edge. So where have we come from? Well, essentially, what we're famous for mostly is analog to digital converters. So we measure whatever's happening in the physical world around us, and we're the best at measurement. So whether it be high-speed measurement for some of those sectors or high precision, I've been in the industrial space where you really need to get the best resolution in terms of your measurement. And then you convert it to digital. And if you think about it, well, there's your data, there's your source of the data. And that's the link to AutoSense. What we do with AutoSense is we say, we'll take what Analog Devices does best, which creates the richest source of data. And we're going to take that data and we're going to do something really meaningful with it. And we're going to interpret it. And we're going to produce an output or an outcome that others can use, we can use, and others can use to their benefit. We'll talk more about what that means. But we've gone much further beyond analog to digital converters, the full, what we call signal chains. So from the sensing and interpretation, wide range of connectivity solutions that I've just talked about. Most recent years, we've added more capabilities to that, mainly some organic, but mostly through acquisition. Doing a lot more in software, a lot more of the data interpretation. And big topic, of course, is data security, especially when you want to implement some of these systems into your facilities. You've got to be able to do it in a very secure way. It's a highly complex set of problems, and we do that ourselves, plus with partnerships. Security at the chip level all the way through the connectivity level to the cloud, and everything in between. And then power. Power is a critically important piece of the element, driving power density down, a lot more efficiency. You can get a lot more channels into the same form factor, and energy efficiency in general is a key part of the company. So I'll not talk to you about everything else that we're doing globally in terms of sustainability and everything else, but I'll just keep it focused on the core technology competencies. So what we've done in our journey is we've gone from the individual chip level to what we often describe as up the stack. And so we add more technologies together to solve more of these problems, get a lot more integration going on. We add the connectivity piece, offering every flavor of connectivity. You've got algorithms either embedded at the edge on the chip, or often now today also in the cloud. You go from multi-chip and then into full stack. You layer in up the stack from chip level to modules, added software, and then comes ADI OtoSense, and we go all the way. So we say, all right, why don't we just try to solve a complete solution if we can? And that's what we're here to talk about today. And part of that journey is not only to create these end-to-end solutions, but it's actually to create new markets for the company, new sources of revenue that takes us just beyond semiconductor. And it's part of an emerging business effort within the company. And we also made a conscious decision that, well, we're not going to do that by ourselves. We're not going to try to get into Industry 4.0 or jump to 2 layers deep into the value chain with end user customers. We're going to do that with partners. And we set off on our journey with ADI OtoSense with a conscious decision that we're going to create a very unique set of technologies to solve very specific problems, which we will bring to market ourselves maybe in the early days, but we prefer to allow others to use the technology and develop their own business models, new business models, like O'Neill has done, where they can go to market and leverage all the great stuff that we have developed. And that's why we're here today. So we're doing things at the edge, we're doing things in the cloud. There's a very complex set of infrastructure that it's pretty easy to be in the lab and create a solution. It's quite easy to have some kind of sensing measurement device and have some data analytics running. If you're a high school student, you can develop some machine learning algorithms. It's actually not that difficult. What is difficult is creating a product that you can actually bring to the market. All the infrastructure that you need to allow these technologies to be used, the financial mechanisms, the data security mechanisms, the whole enchilada. It's a very, very complex process, and that's what my team's been working on for the last couple of years, and we've got it into such a great state now that we're able to enable our partners to go to market. So what we're doing is we're really paying attention to the megatrends across these different industries. We'll talk more about the industrial automation and factory space, but it's really IT meets OT. You've got the promise of the internet, that if it's used in the factory or manufacturing setting, that you can unlock all of this potential for the obvious reasons that you've heard about, right? So more productivity, more uptime, less machine downtime, predictive maintenance, and the list goes on. In automotive, it's more about safety, if you like, more autonomous technologies going into the vehicles. We're enabling all of that. In the healthcare sector, similarities there is that you've got a previously very centralized healthcare system where you've got clinics and hospitals where people need to reside for a certain amount of time, and that's transitioning to more remote monitoring where you can have patient health monitoring at home, and that transforms the entire ecosystem of that industry and the financial elements of it as well. Our interactive devices are becoming more augmented, and our connectivity is becoming more ubiquitous and self-managed as well. So this is lending itself to creating a lot more value of what we call the edge. Now I'd say on Industry 4.0, where I've probably spent a lot of the last 10 years somewhat involved in, there's been a lot of hype, there's been a lot of discussions. You go to any of the big trade shows, there's an enormous amount of new technologies, lots of innovation, lots of ideas about unlocking data and sprinkling sensors all over the place. Taking all of that data, making the best interpretations of it, having factory to factory or enterprise to enterprise data analytics. And there's lots of layers in that. There's lots of companies, software companies out there that are offering great promise and potential. I think the reality is that it hasn't come through yet. It hasn't manifested itself yet. It hasn't realized that full potential. And I think we're still in the early innings of Industry 4.0 or these big digital transformation ideas that we hear about. So why is that? Well, I think there's still a lot of work to be done. There's, as I said, there's a complexity to this that hasn't been wrestled with well enough yet. And what I mean by that is I think what's happening is that you've got folks like us and many others that are solving individual problems. So I say islands of problems. There's no one solving the whole problem. There's no Microsoft or IBM or GE or whoever is kind of rolling in, and even if the Amazons and the Googles of this world will try to convince you that, hey, just send us all your data or give us access to all your data and we're going to solve all your problems. Well, they're far from figuring that out. And there's lots of ingredients missing in that formula. So our approach to this is, well, we're all on a journey to get there. And while we're on that journey, we've got to start somewhere. And we're going to start with what we're best at. And with ADI OtoSense, we said, well, with analog devices, we're kind of really good at measurement. Okay, so let's use ADI OtoSense to take the best measurement and do the best interpretation. How much value can we extract from that, and how do we actually put that into a product or a set of products that our customers can use? And not the traditional ADI customers that buy semiconductors, but folks who are at the machine level, folks who are at the plant level, the shop floor level. How do we actually make an impact today? Big part of our strategy and our business model plan is to, as I said earlier, is to work with partners. So in order to try to make big steps forward in realizing the big promise of Industry 4.0, we've got to develop new networks and partnerships, both horizontally as well as vertically. One partnership that we've developed locally is with O'Neill. That's one of many. We're partnering with Microsoft at the Azure level, as well as some of the go-to-market activities. We're partnering with Hewlett-Packard Enterprises on hardware and services. We're partnering with motor repair workshop companies, system integrators that have never heard of analog devices before, never bought a semiconductor component before. So we're developing quite a complex set of partners in that whole ecosystem in order to kind of accelerate us through this journey to get to a much larger ambition. So I think we're in the early innings, and it's really exciting, and I'm comfortable with that. I think we've got to go through that process. So I think we're far from really realizing Industry 4.0, and I'm sure you folks in your own fields are realizing that hey, there's a lot of hype out there, but how do I make it real? There's an abundance of technologies. Many of them are startups. Some of them are the big cloud folks, but I say they're missing those ingredients. One important ingredient is it's easy to make the technology relatively. It's difficult to turn it into a product that you can consume and rely on safely. So let me get you into it's a pretty simple product strategy. There's two product strategies to ADI OtoSense. The hardware is a means to an end, which is counterintuitive for someone from analog devices. It's basically a hardware semiconductor company. But for us in ADI OtoSense, the hardware really just has to work. On the right-hand side of the screen, you'll see the AutoSense PDM, which is Predictive Maintenance SMS Smart Motor Sensor. I'm not going to talk to it because I'm going to pass that over to Michael O'Neill. I'm not going to steal your thunder. But that orange box over there that you see, or this one here, inside that is a bunch of analog devices components. There's a bunch of other components from some of our competitors, which we needed at the time. And internally, folks ask me, well, why is it not all ADI? And my answer is, well, I don't know. I don't really care. It just has to work. It's a different mindset. The key is that the hardware just has to work, and then the magic is in the algorithms. In this particular platform, those algorithms run in the cloud. So this is a full IoT sensor to cloud infrastructure with all of the security built in and so on. And it's a phenomenal product, and Michael's going to talk about it. On the left-hand side with AutoSense, this is really a software play. The one on the right is specific for electric motors. The one on the left is, well, what about all those other machines? There's no sensor to cloud application on the market that is so intelligent with all of the domain expertise for that machine built into the algorithms, and that's sitting in the cloud. There's no domain expertise sitting in the cloud. So what most people do is they say, well, there's lots of data that I can get from these machines. Either the machine is providing me data or I'm going to attach some sensors. And then I'm going to go hire a whole bunch of data scientists and mathematicians to try and figure out what the data means. But they don't have the expertise at the machine level. The machine experts have very little understanding of AI and machine learning algorithms, as far as I can tell. And so there's a disparity there. So people are throwing mathematicians and data scientists at data problems, but they're not connecting it with the machine and the domain piece of it. And so it stalls again. So we said, well, there is a problem to be solved. And we have this thing called OtoSense, which is really a software platform. It's a tool. And it's not only a tool, it's also a product. So it's certified. You can actually use it in production. You can actually connect it to PLCs. You can connect sensors to it. It's independent of sensing modalities. It's independent of hardware. It's independent of machines and industry. So essentially what it does is it will take data from sensors. Most common applications are using some form of vibration sensing, either in the form of microphones for acoustics or accelerometers for vibration. Sprinkle in some temperature sometimes. It will take pressure, electric current, voltage, whatever you like. And for those unidimensional sources, it will pull raw, when it's really good is it pulls raw data from sensors in real time. And it will make very quickly an interpretation of that data. And it's so clever, it will make an interpretation of the data and generate its own model. You could call it an AI model, right? But it's a model. And we have some customers that say, hey, I'm going to send you some data so that you can interpret it for me, and then I'm going to provide you with some documentation to tell you about the data. And we say, no, don't send us the documentation. We don't want you to tell us about the data. We're going to interpret it all by ourselves. And then we're going to show it back to you, and we're going to tell you what we interpreted from it. And then you can decide whether this AutoSense thing is of value to you or not. So we take it that far, and we will generate models very, very quickly, by the way, a very finite amount of data, and we could generate, if it's a single sensor source, we'll generate a model in a couple of minutes. If it's multi-sensor and it's a complex system, it might take an hour or something, but it's not like weeks of learning and so on. Now, the thing with those machines, unlike the electric motor where we have the expertise in-house and it's built into the algorithms, there's too many machines out there that are, the variety is too broad, and we'll never acquire or hire enough people that will have expertise in those machines. So AutoSense, in that case, we use as a tool that makes that interpretation, and we put it in the hands of people who don't need to understand AI and machine learning, but who do understand their own environments, their own machines, their own production lines. And we give them that tool so they can interact with it. So they can take those models, they can look at the output of those models, and they say, yeah, this is good, this is accurate, I can use that. I can use that for health monitoring, predictive maintenance. I can use it for continuous monitoring, field diagnostics. We've actually honed ourselves down into a specific area around quality control for the end of the manufacturing line. And that's part of our growth journey. It's like, okay, we're solving significant problems there, and AutoSense really lends itself to that environment. I'll give you a couple of examples. So it's really about putting AI in a simplified form in the hands of machine experts who don't need to be data scientists to use it. And they can use the models that it generates for their use cases, but they can also teach the models more. They can interact with the system so that they can educate it. Okay, so your model just told me that my machine has a problem. It detected an event or an anomaly and displayed it. And it turns, well, AutoSense doesn't know what that anomaly was because it doesn't understand the machine, but you do. And you can look at that and you can say, well, I know what that is. That's a lubrication problem. Or, hey, something's loose and it's vibrating. Or the audible noise that happened there was an anomaly that I understand because I have 20 years experience working in this environment. So I'm going to take that AutoSense model, I'm going to tell it what that was, and I'm going to label it. And so it knows for next time. And actually what's happening is it's learning from you as you do that. So it's a software tool. It's very flexible, and you can scale it across lots and lots of different applications. So we just happen to be working with a lot of companies for example, in automotive manufacturing, where they're using it to improve their quality scoring of their assets as they're being manufactured. So let's say, for example, you're building let's use the compressor example, right? So you're building a compressor and you're selling it into the automotive markets, going into cars. But your compressors that you're building, as they get to the end of the manufacturing flow, you've got some kind of test and quality processes going. And you've tried to implement some clever techniques to get a quality score. You're using some people as well. They're listening, they're monitoring something. And once you reach the limitations of those physical implementations and you still have a problem to be solved, that's when folks turn to OtoSense AI to go to the next step. So where we've had customers that say, well, our people have been listening for a rattle defect in the compressor before we ship it to these German car manufacturers. We're only catching about 75% of the problem assets. We come in with some acoustic sensors and vibration sensors, set it up, train the model, and we're able to detect 100%. Some of them might be in an area where it could go either way, but at least you can take those off the line and go retest them, and then you can decide. But very impactful, and there's so many applications where video systems kind of reach their limitations as well. And so taking these acoustic measurements and vibration measurements, there seems to be a lot of applications for that. So that's why we find ourselves kind of playing in this quality control space. But AutoSense, as I've pointed out, we were working with US airlines to detect problems in starter units in the engine manifold at the gate at the airport, to metal stamping presses that you need to detect the successful extraction of shards of metal as you've pressed something with the tools. And sometimes those metal extraction chutes get clogged up. When they get clogged up, that's a huge 3-story machine shuts down and your production line is affected. Well, we can accurately detect when those chutes are actually starting to be clogged up so that they can go and intervene before the whole thing breaks. And I could just keep going. There's just so many examples where we've been active. So I've kind of explained what this is. It's really any mechanical part of process, any sensing modality. We can take data from automation, so the PLC can say, hey, I want you to start a session, stop a session, give me the insights back. Local processing, that's the difference between this one and the electric motor one, which is cloud-based. Everything I just talked about is actually happening at the edge. We're not sending it to the cloud. There's too much data involved. There's too much latency involved. That real-time continuous data is being interpreted right there at the edge continuously. And the richness of it, we don't miss a heartbeat. You try to send it to the cloud, it's taking too long. It's quite expensive. There's too much data, and you miss most of it. There's about 4% of the data that you actually are dealing with, which is useful. And you lose all of that resolution when you send it to the cloud. With the electric motor one, it's different because you can manage it differently, and that works very well in the cloud. So pretty much that's what AutoSense is. It's an AI solution, raw sensor signals, automation data, talked about the human expertise interacting with it, and it provides you with that automated quality score. So that's where we are in the journey. So what we're doing is we are not only solving all of these problems. What we've done ourselves as ADI OtoSense is we've gone to companies that really don't interact with analog devices traditionally. We've worked with airlines, we've worked with food and beverage manufacturers, we've worked with auto manufacturers, energy companies, utility companies, you name it, the whole gamut. And we've solved lots and lots of problems for them. But our real play here is that we want to enable industries to kind of do this by themselves. We don't want to do all that ourselves. That's not our business. We're an innovation company, and it's our business to enable you folks, and also through our partner network, to solve more of these islands of problems. As we do that, our partnerships will keep expanding how ADI OtoSense can be embedded and interfacing with, let's say, automation company software infrastructures. It might be a Schneider or a Rockwell or a Siemens or people that you're familiar with. How can system integrators embed or use AutoSense to solve more problems for you as well? And so we're on that path to enable all that entire ecosystem to try to leverage this stuff. You know, we're working with J&J, we're working with a lot of different folks to try to join the dots, so that maybe in a few years it won't be just islands of problems. We'll be an important ingredient in the bigger enterprise level problem solving piece of it. So hopefully that made sense. Hopefully that gave you enough context about why we're even here today, what this ADI OtoSense thing is, why O'Neill has embraced it. And with that, I'm going to pass it over to Michael O'Neill to introduce you to what they're doing with our sensor and what the plan is. Great, thank you.
So I'm Michael O'Neill of O'Neill Industrial. Most of you are familiar with the company, but for some of you who may not be as familiar as others, we're a family-owned second-generation business involved in the supply of compressed air equipment, air compressors, pneumatics, and pumps. In our time, we have built numerous key business relationships with the most respected names in manufacturing across a spectrum of industry. One of our key objectives as a company is to bring leading and cutting-edge technology to our customers, and we certainly see Industry 4.0 as that opportunity. To meet that commitment, we are delighted to have partnered with ADI. They themselves a most respected name in industry and a leader in Industry 4.0 technology. So I'm here to talk to you and give you an introduction into an ADI Industry 4.0 device for electric motors called the SMS Smart Motor Sensor. I was first introduced to Industry 4.0 a few years back, and it was clear to see it was the future. Terms like factory of the future and Internet of Things was becoming commonplace. And the question is not if, but when we will start seeing this technology as ubiquitous part of manufacturing. Would that appear both in acquisition of new capital equipment, which would be Industry 4.0 enabled, or would it be available as device you can, excuse me, you can retrofit to existing equipment? And that's exactly what the SMS is. It's a device that you can start your Industry 4.0 journey with, or continue your journey if you've already started. So I'm going to play a video to give you a better understanding of the device in question.
Machine maintenance is hard. The sheer volume of motors in your facility and variety of motor types means you need to employ costly experts or a range of solutions to cater to the array of assets you might wish to monitor. Route-based maintenance approaches are challenging and can still miss critical warning signs, which result in unplanned downtime. They also don't alleviate the need for scheduled downtime on critical assets, whether it's required or not. What's needed is a robust turnkey hardware and software solution, agnostic of motor type and delivering benefits such as maintaining critical production conditions, optimizing energy generation processes, and augmenting the delivery of critical goods and resources across multiple industry segments. A platform that covers the most critical diagnostics built on decades of experience, all from a partner who are at the forefront of translating environmental data into actionable insights and coupled with a great user experience. ADI OtoSense Smart Motor Sensor is an AI-based high-performance predictive maintenance platform. Created by Analog Devices, the leader in interpreting real-world physical measurements, the Smart Motor Sensor allows for 24/7 monitoring of all your low to medium voltage electric motors. ADI OtoSense SMS uses analog devices' best-in-class sensors, measurement techniques, and algorithms to provide meaningful, actionable insights. ADI OtoSense SMS measures multi-axis vibration, magnetic field, and temperature conditions of the motor. Once mounted, the smart motor sensor automatically initiates a learning mode, creating a unique model of the motor as it operates in your environment. The model is customized to each motor and enables mechanical and electrical fault diagnostics of the most common fault types. A performance indicator identifies potential systemic issues that are indicative of a load problem or process change that may require further action within the manufacturing process. Unlike other systems which provide limited, lower quality data, ADI OtoSense SMS provides diagnostics and severity level insights along with recommended actions to address them, therefore minimizing unexpected failures. ADI OtoSense SMS enables easy to set up real-time monitoring in a matter of minutes, allowing you to extend your predictive maintenance strategy beyond your most critical assets. ADI OtoSense Smart Motor Sensor unlocks operational efficiencies such as more informed maintenance planning, spare parts inventory management, and increased uptime, ultimately optimizing your manufacturing environment while simultaneously reducing costs. To learn more about ADI OtoSense, visit otosense.analog.com.
Smart motor sensor, advanced predictive maintenance for motors. What this device facilitates is the movement from predictive maintenance or preventive maintenance to predictive maintenance, where you move from a situation of trying to get out ahead of an unknown problem to actually getting out ahead of a known problem, which reduces downtime and reduces costs. The system itself is made up of hardware and software. The hardware, which is attached to the motor by clamps, and it's a wireless connection between the sensor and the motor, and it is one sensor per motor. The sensor itself, wirelessly over the air, communicates with a cloud-based artificial intelligence, which itself distills all that data from the sensor and delivers to you, the end user, actual diagnostics. So in effect, what the sensor does, it gives your motor a voice to tell you how it's feeling. If it's not feeling well, it'll actually tell you what's wrong with it, and it'll tell you what it needs to be done. So it is a tap on the shoulder required to take action before a serious failure occurs. So I mentioned the sensor itself, the piece of hardware which contains 5 sensors. Analog are renowned globally as best in class for measurement sensors, and they have applied their technology to this device. Which in turn it monitors your motor 24/7 and sends that information to a cloud-based AI, which furnishes you with actual diagnostics. Before the system can do that, it has to learn your motor. It learns that over a period of time. What sets this device apart is that it self-learns, which means that you don't need to go in and set up the parameters for which you want to receive alarms, nor do you need to bring an expert to do that for you. So you avoid the risk of setting your parameters maybe too wide or too narrow, where you don't get enough alarms, if any, or you get too many. This system only sends alarms when it's necessary. So from that baseline understanding, the SMS will send you actual diagnostics over 9 different parameters that it's continuously monitoring on the motor. And it also includes a level of severity as to the problem. So I mentioned there are 9 different parameters to which the sensor measures. They are power system, stator winding, rotor, motor shaft balance, eccentricity, bearing, alignment, cooling system, and loose foot. Looking at your platform, be it on whatever device you are looking at, be it your phone or your desktop, laptop, you will see this exploded picture of your motor. The system will identify the component in the exploded picture and will also give it a color coding as to the severity of the problem. There is a 10th called performance. From the baseline understanding that the system has of your motor, it can also detect that the motor is working fine. All components are in good order, but something has changed in the performance of the motor, and that may be the load. So it gives you a notification that something has changed in the process, something has changed in the load, and it should be checked out. So this system gives you a bumper-to-bumper coverage on the motor itself, but it also gives you a tap on the shoulder regarding the process it's operating, if something has changed in the motor's performance. Automators, we have pretty much covered this already in the sense that the device is self-learning, but it customizes its learning to each motor. For example, you may have 2 identical motors in 2 different applications. It will learn each motor individually in its own application. As I mentioned earlier, again, the system is wireless, so there's no need for running cables when you are rolling out the SMS in your facility. It's very easy and quick to set up. The SMS is deployed throughout 30 countries, across numerous industries, food and beverage, paper, pharma, semiconductor, utilities, and chemical, many of which you represent here today. So to wrap up, I would like to thank, on behalf of O'Neill Industrial, Mike Morrissey for making this fantastic facility available here today, for Jason Griffin for being a great friend to O'Neill Industrial in recent times in building our partnership together, and for Kevin for travelling from the States to deliver his keynote today. So thank you for listening, thank you for coming, and enjoy the rest of the morning. We will be carrying out demonstrations for the remainder. Thank you.
You're going to take some questions? Go ahead.
Hi, good. I'm Ian Collins from Richardson RFPD, we're a distributor. But a question I have for you is, what connectivity do you have on that in terms of wireless connectivity? Is it Wi-Fi, or are you using narrowband IoT or something like that?
It's currently Wi-Fi based.
Okay.
Yeah. Lots of roadmap discussions on adding more options to that, but it's currently Wi-Fi.
Okay.
Yeah.
What's the battery life of it? Is it rechargeable or replaceable?
The battery life is, it's kind of a moving target at the moment because there's always ongoing efforts to improve it. I think the current setup is, Jason, you're going to correct me, right, that battery life should last you a minimum of a year, and it is replaceable. So it's easy to just take that cover off and replace the batteries. Jason's team in particular are doing a lot of work. Battery life is dependent on how much data you send and how often. And so there's a lot of work being done to kind of optimize that. So we're going to see improvements over the next months on that. Sorry, just wanted to back there first.
Yeah, I was going to ask the same questions about power and about connectivity. So Wi-Fi is a problem inside steel CAD or steel construction buildings.
Yeah.
And also you look at the possibility of induction charging because it's not a perfect piece of equipment. So the one battery could be eliminated.
Yeah.
So you just do induction charge at the phone and you have a rotating magnetic field.
Yeah.
So it'd be very easily done.
Yeah, that's certainly part of the roadmap discussion. It's going to be ongoing efforts to try to pick the right path forward. So I'm not sure if that one was on our list, Jason, but we should definitely add it.
I'm gathering data from a wireless device. So if we look at particularly power generation, okay, so if we look at substations, so they gather data, but they do them, there's various different protocols for gathering data on distribution networks, of discrete devices, and they have them on waterworks and a lot of different applications, and they don't just use Wi-Fi.
Yeah.
So there are a number of protocols out there which we looked at. But Wi-Fi is rather limited.
It is, yeah. So our experience so far on Wi-Fi is you've got to start somewhere. So Wi-Fi was a useful place to start. And what we've noticed, we use this ourselves in our facilities here and also in Wilmington, but also working with our customers. You find that in some areas it's fine. You've got plenty of signal. It's more of an IT topic. So typically what happens when we engage with our end user customers is they want to see this thing in action first. So they'll do a trial for a couple of months. And you can do it locally, you can do it via Wi-Fi as well, but typically Wi-Fi. What we tend to do is then set up an independent Wi-Fi link. So it's hidden from the corporate Wi-Fi that your IT department will be very sensitive to. When it comes to those environments where the signal integrity is compromised, either with an individual or extra router that we place in there, we kind of circumvent that, and also then to a GSM link. So typically what happens is once the engineering or technical teams want to see the performance of the sensor, which is priority, they realize that, hey, this is good, this is the best on the market actually. All right, let me get my IT department involved to make sure that we get the signal integrity that we need. While we're doing that, so far we've managed to solve all of those problems for our customers to date. There might be some exceptions where the location of that particular machine is just not going to allow that to happen. And so roadmap is to make sure that we've got those additional communication options so that we're not relying on Wi-Fi exclusively.
Just curious, what's the data rate like in terms of when you're transmitting information, and like what's the frequency of transmission? Like is it once a minute or something like that?
You might know the data right. I know currently we're transmitting about, is it once every 20 minutes or has that changed?
Yeah, there's an accelerated learning whereby it learns the motor over a period of a short time. But right now it's listening to data every 20 minutes, so 3 patterns every hour. And it equates to about 500, just under 500 megs per motor per month.
Oh, per month, okay.
Yeah.
So what's that every 20 minutes then? Like about a couple of kilometers or something?
Right. So the learning, depending on how often you're sending packets, you can do the learning in a day or you can do it over 2 weeks. And then once the learning is complete, it goes into monitoring mode, and then I think it's defaulted to once every 20 minutes.
So a quick question on the QCS version of OtoSense.
Quality control, yeah.
Yeah, and you said that because of the sensor diversity and all the data, the analytics were generated locally, the insights were generated
That's right.
locally. Is there a cloud connection to get those insights up to the cloud?
Yes, of course. Yeah. Right. So with the quality control, the one that was on the left-hand side of the slide, typically you've got multiple sensors, and it's about that continuous monitoring at the edge. So it's done locally. So what happens is the model itself sometimes is generated by us, and then via the cloud through backdoor, we'll then we'll place that model at the edge device. but then it's continuous monitoring at the edge. What it'll do is it'll generate, it'll extract the useful data and generate the insights and learning. Now that's a finite set of data, right? You don't need that in real time. You do locally at the edge on a screen, or it might be a light tower or HMI that you want to look at, right? See if something's going wrong. But if you want to extract that data for future purposes, then you can just, typically what happens is there's an edge box, customer, it's their data, keep it on premise. They might store the insightful data on a server, and then that can be transported anywhere you like. So that's not real time. It's typically what happens. Yeah. And that takes care of all the data security topics as well. But.
So can I ask you a question? Just say you would want to get Siemens motor, a large motor driving compressor revenue maybe. What I understand is, are you keeping the wrong data from day one? Because if it's smaller, it's in place for 5 years. What are you basing your data? Is it getting, you just said it's slightly in trouble, winding squeak or doing wrong.
Yeah.
So the original manufacturer's data for the motor, are you basing it on their data, or are you just learning from the machine or flash? Because I just see that laser learning and things like that as well.
Yeah.
They all have to be fully set up first before it allows you to lock onto it before you put out the AutoSense. I just confused this.
Yeah, it's a common question. It's a good question. So, another way to ask that is, well, ideally the motor is perfect and you know everything about it in advance, and therefore you know that it's set up, right, to predict any potential failure perfectly. Well, what happens if the motor's not healthy? Well, it's a combination, and I'm going to be corrected if I get this wrong, but it's a combination which is the team that have developed this platform and the algorithms, not only are they 25-year PhD experts in motor design for these manufacturers, but they've also got all of the historical data for a majority of the most commonly used. And so there's reference data from the OEM, from the motor OEM. The learning process is sophisticated enough that it will know that, hey, hang on a minute, there is actually something wrong with the motor, even though I'm learning about the motor. And the learning process itself is a diagnostic tool. So what typically happens if there is a fault with the motor, even before you get to monitor it, you're just learning it. That loop, that software loop, that the learning process never ends. It can't come out of it. It can't stop the learning. And that itself, after a X period of time, usually within 2 weeks, if it's every 20 minutes, if it's stuck in the learning loop after 2 weeks, you know that there's a problem with the motor. And so that in itself is a diagnostic feature that says, you got a problem. If the motor is good enough and it's healthy enough, the learning process will complete and it will switch into monitoring mode. And then it will tell you the status of each of those line faults. The other solutions on the market today, they'll do a certain amount of that. Typically, this is the difference. This is really important, by the way. This is what separates this from the noise. There's plenty of solutions on the market. Some of them are startups, some of them are from the OEMs themselves, like Siemens and ABB. Some of them are sophisticated enough to tell you whether the motor is running or not. That's about it. Others will tell you that, hey, there's a problem with the bearings, which is one of the most common faults, but that's about it. But they also have teams of people sitting in China reading through data from each machine to try to find the problems. This doesn't do any of it. This is all self-automated. And it doesn't just tell you that the machine is on or not. It gives you those 9 diagnostic faults with accuracy. And will tell you, not only do you have a bearing problem or a shaft misalignment problem or a loose foot or something like that, it will give you a severity rating between 0 and 10. And depending on the severity rating, it will display that to you. Say, okay, we've detected a misalignment with the shaft or a loose foot or a bearing problem. And on a scale of 0 to 10, it's this. And a certain score might be, it's starting to be a problem, it's not that severe, you don't need to lose sleep about it, but you might want to have your motor technician or engineer take a look at that next time. But you don't need to shut your motor down in the next 2 weeks. It might be okay to keep running it. Or it might be so severe that it's like, hey, you need to get this fixed immediately. You will not see any others on the market that does that. The 10th one, so you go through all those diagnostic features. The 10th one we call performance. And this is another unique feature to this, is that the motor itself, when it goes through the learning process, is based on a continuous operation of the motor in a consistent environment. In other words, the load isn't changing. It might be a conveyor belt, it might be a fan or something like that. But quite often you'll have a motor where the load changes. Right, so you'll have some kind of variation in the load. It might need more torque because you put a heavier load on it, or it's behaving differently because of the load. The performance feature on this will detect that. And then that allows us to say, well, hey, there's an indication that there's some kind of misalignment, but it's more to do with the load change rather than the physical shifting of the motor itself on its platform. So that's an important feature as well. And then that allows you to say, well, okay, the warning that we just gave you is not one that needs fixed, it's actually just a load issue. And because you changed the load, it'll actually go back and relearn based on that. So it's a very sophisticated platform. And we don't have any people sitting behind scrolling through hours of data to try and find anomalies. It does it in real time by itself. Right.
The data is so low, so the roadmap to set it up connectivity for environments where maybe a motor wouldn't be fruitful.
Yeah, as I say, the roadmap's not fixed yet. What we're doing is we're looking at different options on the connectivity piece. Another part of the roadmap, by the way, is that if the OEMs want to use this for their new machines, they could actually power the device, and therefore you don't need the battery, which is an answer to a different question. But currently it's Wi-Fi. It'll be Wi-Fi, I'd say, for the next year. And then we're actually looking at a couple of options, both on the cloud connectivity piece, but also on the commissioning piece with low power Bluetooth, so it's much easier and faster to commission the device as you install it. So, but you're kind of stuck with Wi-Fi for about a year. We're also moving and have moved for the next generation to IP certification, so outdoors, waterproofing, and all of that kind of stuff as well will be supported.
What's the current rating?
I can't hear you.
Sorry, what's the current IP rating?
It's 55. Yeah, soon to be 67. It's in discussion. Yeah.
Just a lot of plants have multiple redundancy, say 3-4 units of the same design. So does it have any comparator function, or is each set of data standalone?
Quite often you see redundancy. We have instances where they'd like to have the sensor on both the main and the redundant motor. Every unit is an individual. So as I say, we've got that background data from the machine, the OEM, and actually during the commissioning process, you will physically, on the app or on the web interface, type in the boilerplate info from that machine. And we'll have that reference data from those machines as a template. But every motor, through the learning process, develops an individual model in software for each individual machine. And that's how it works. Not sure that answers your question.
No, I'm just saying, if you had, say, 3 individual, or sometimes some places you've got 10 identical company units there, or whatever, right? You think that the drives or whatever, has it any comparator function? Because a baseline of one installation, the exact same equipment in another installation could be different, okay? But on a train, on a line, a production line, 3 or 4 motor pumps in the road, compare one to the other.
We were just
more applicable or more practical in that particular installation.
We were actually just talking about this in the last few days. So it's a bit manual and rudimentary at the moment, where you can take a screenshot of each one and kind of overlay one over the other and physically look at it. But that comparator function is something we've been discussing that we can build into the software. No, so we don't have it yet, but it's doable.
Is there an API into the program that you can pull out that data into a third-party platform and do the comparisons?
There is, and my API expert who's developed it is sitting right there.
Yeah, so there is an API, customer level API, so if you sign up as one of the customers, you automatically access the API. The authentication is based on OAuth, and you control every single item you see on the network at whatever frequency you want. You can even actually go as far as building your own mobile application device. It's built on a RESTful API, so it's your standard. And it's not limited on the number of API calls, but there is a number of threshold API calls.
So I guess through that route you could do the comparison piece. Yeah. Well, your dashboard, for your individual dashboard, you will have access to all of your motors. If it was a machine with multiple motors, you will have a screen with each individual motor. So there's one sensor per motor. It's not going to give you a combined machine level abstraction. It's really just telling you the health of that motor. And if you have 5 in a machine, you're going to get 5 individual. You'll see it on your screen. Yeah, we're not at that level of insight. That would be a level up. So through the previous questions, I think we've answered that, hey, there's some ways to get there, either through the API or you would do it. At least you would have visually the information on each of them that you can overlay and look at simultaneously, and then you could maybe extract some value of that. We're not at that machine level of abstraction where we're offering you a higher view on it. It's possible, but think of this as individual for each sensor. I think you just come up with another. The point I was making earlier when I was talking was we're solving kind of islands of problems. We haven't figured out how to bring it all together yet. That's a good example of just even the next logical step. Right? I mean, it's doable, but right now think of this as resolution at the sensor level per motor. But the information is available to you to allow you to make those comparisons yourself. We're just not presenting you with a dashboard that allows you to do that automatically. Exactly. Yeah.
We do allow you to tag motor based on location and process. So if you just multiple motors on the process is planned, so that's the whole information.
Is there a limit to how large the motor can be? And I think you mentioned it was small and medium-sized motors that you could primarily the sensor design for. What's the limiting factor on the size of the motor? Like your sensor couldn't work with that level of flux or something? Or?
Yeah, we started off, people that developed this started off with a really high-end manual system where experts need to go out and place sensors across. So we have a Rolls-Royce version of it that we don't publicize too much. It's just too much effort. So this is more of a low-touch, easy-to-use, self-install, get up and running, and it works really well. The limitation is a physical one, so we say low-voltage motors. I can't remember exactly the kilowatt limit that we go to, but it's a physical size piece of it. So if you've got a larger machine at medium voltage, the sensor is just too far away from the action. Like a single sensor is just too far away from the action. So what you end up doing with it, what you can do with it is place 2 sensors on the machine. The other thing we're doing, by the way, is that quite often the motor is obviously driving some kind of a load, right? It could be a gearbox or a fan or a pump, compressor, whatever. And sometimes then you have actual issues with the load and not with the motor. What this sensor will do is, let's say it's a fixed drive. In other words, you're not using belts. So you've got a fixed drive load, and the physical proximity to the motor is close enough that if you've got a bearing problem in the load, this will pick it up and tell you, hey, you've got an issue. And we're actually developing out that load sensing software piece of it as well, and a new form factor for the load. So you'll see on our roadmap that we've got sensors that will actually go on the load and then communicate with this box as well. So that's the next phase of the roadmap.
I think the upper limit for kilowatt rating is 500 kilowatt.
Yeah, thank you.
And what voltage?
I can't do it.
At what voltage?
Do you remember the voltage?
6.6.
Can't remember.
Kilowatts is really
Yeah.
old.
This one definitely be 3-phase for 140 AC.
Yeah.
It has to be, if it's taking up to 500 kilowatts, you can never be taking it.
You think I know what I'm talking about? I have experts in my team that do this stuff. I'm just quite proud of myself being able to answer so many questions. Can't believe it. You can use our AutoSense platform for that. That's what it's designed for. It's not only quality control, but it's a data arbitration tool, so you can plug any sensor into it and then bring it all together through AutoSense. Think of AutoSense as a brand.
Any sensor, is that from any, let's say, IFM sensor or PLs into this platform?
So this orange box is not going to interact with any other platform or any other sensor modality. The other piece of the AutoSense quality control, that software platform, you can connect any sensor to it, and it will interpret the data. Let me be specific about interpretation. So what it interprets itself in terms of its own model creation and interpretation for anomaly detection and event recognition. It takes what we describe as unidimensional sources. Single dimension, so voltage, current, pressure, temperature, acoustic, whatever, and makes an interpretation. What it's limited to and cannot interpret is three-dimensional data. So if you fed it a video source from a Cognex camera, for example, AutoSense will not interpret that video data and derive meaning from it. So it's unidimensional only. What it will do with the video data is use it as context. Say, okay, I'll take that video data and it's going to tell me something about what's going on. I'm not going to interpret that data. So for example, we've got applications in automotive manufacturing where part of the assembly process is where you've got humans connecting cables. It might be the steering wheel to the steering column in a Tesla or the head unit or something like that. And you wouldn't believe it, but there's just one cable connection determines whether the car is going to work or not. And you have humans in part of the manufacturing process that will put that cable together. And if there's a bad click, you get an unhappy customer or an unhappy Tesla employee and they send it back and there's all sorts of ROI problems. A good click means a good car. AutoSense will determine whether that connection was a good one or not by audibly listening to it. Okay, well, there's a lot of noise going on, and when you start listening and when you stop, well, there might be a computer vision camera above that's looking and tells AutoSense that human's about to make that connection. So AutoSense will then come in and say, right now I'm going to listen really carefully to what they do and ignore all of this other background noise. So you can see how we're able to connect with PLCs and other sensing modalities and use that data as context. But the actual data interpretation and modeling is on the sensors that we're really listening to, whether it be acoustic or vibration. Most use cases are acoustic and vibration. So AutoSense, you can plug any sensor into it. Unidimensional, it will interpret. Three-dimensional, it will just use its context.
Verification device for just say there's 100 of these on the site, and I'm sure each one of these are going to need a SIM card, so they don't communicate directly with the cloud. They must be a device they communicate with.
Yeah.
Connects to the cloud.
Yeah, you nailed it. See if I can very quickly get us back to, there we go. This is AutoSense, independent of the electric motor application, so it's for all those other ones. You'll see the sensors, and there's a black box. And we don't build it. We've certified from at least 4 or 5 vendors for that. So one is HB Edgeline. Another one is WebTech, another one is Advantech, another one is National Instruments, AD Link. I think those are the 5 that we've used so far. We're working very closely with HB, the Edgelink device, and you don't need cloud connectivity because it's all local processing. But it will connect to a PLC or a controller or whatever you want it to provide communication to the cloud if you want it. That particular Edgeline box from HPE will take many channels. So you can have one box sitting in the locality and actually run 5 or 6 separate AutoSense applications simultaneously. It's got enough processing power and interfaces, I/O in it to do that. The WebTech box is smaller, might be useful for one application.
So that sits in the area where the AutoSense tech communicates with that?
Yeah, it's all local. It's right there on the shop floor. Yeah. There's no cloud connectivity needed, there's no Wi-Fi, there's none of that. Yeah. How come I'm getting all the questions? Go ahead.
Yeah, another API-related question. I'm in the agriculture industry, and I know most of our customers have an existing CAPI automation system. Have you ever worked on the roadmap to interface with the CAPI automation system?
Sure. Well, first of all, this box, the whole API capability is there if you want it. So all the raw data, all the insights and everything else, you can channel and do what you like with it. You don't need to use our, let's say, UI platform. For the AutoSense piece of it, the software that we've developed together with whatever hardware platform we're using interfaces to any automation system. So you can link it to drivers in there for any Ethernet protocol. You can link it through Ethernet IP, Profinet, all of the controllers, whether it be Allen Bradley, Rockwell, Siemens, Schneider, so on. We're actually working with some of them in some of those end customers where big European car manufacturer where we're solving problems for them. They're saying, well, we don't want to use this edge DAC thing. Can we use Schneider? Like, yeah, of course. We're partnering with Schneider just to implement that. So, no problem. Sold?
Just one more question.
Go for it.
Maintenance management systems, like Maximo or whatever,
does it
link?
Does it link?
Yeah.
No idea. I'd say from a interfacing perspective, I think the possibilities are there. I don't know of any example where we've had a direct interfacing with one of those. We are working with some of the large system integrators as well who are kind of picking up the slack in some of those higher level interfacing. But no, I don't think I can answer that question accurately. So I think, what's the plan? There's a demo. I'm not sure you've had a chance to see it. Quite often it's easy to present slides and talk about all these cool features of the orange box. It's a lot more fun to see the demo, and we can induce a lot of those faults as well, so that you can see it in action. O'Neill will offer you the platform, the trial kits, the support. We're standing behind O'Neill with all of the expertise, should they need it. So great source locally to get your hands on this platform. It really is the state of the art. We're going to keep improving it, but it's the only one out there that does what it says on the tin. It's pretty remarkable. All right. What's the plan? I think we're going to.
So I'd like you to post the image.
Yeah. Perfect. Thanks everyone. Thanks for coming. Thanks for your time.